Welcome back to 5-Minute Chemistry. Today we are going to be breaking one of the fundamental rules in Dalton's atomic theory, which is that atoms cannot be subdivided, and we will rip off an electron from an atom and dividing it. So J.J. Thomson was doing his experiment in 1897 with a vacuum tube. In this vacuum tube there were 4 electrodes, and 2 of those 4, the blue and the red one here, were used to apply a high voltage which would generate the movement of charged particles between these 2 electrodes. In the red electrode here, there is a hole in the middle, which meant that once the high voltage is turned on, some of these charged particles could escape and reach the other end of the vacuum tube, where this particle beam would collide into this screen, this chemical on the vacuum tube that would light up bright once the particle beam meets with it. And based on that, it was possible to see the trajectory of this particle beam. The other 2 electrodes, which are portrayed in gray here, were used to apply an electric field. So if the electric field is turned on, you can change the trajectory of the beam. And here, the force that the charged particles in the beam would feel is proportional to the charge they have, but how much this force can accelerate them or change their trajectory is dependent on their mass. So based on this experiment, Thomson could show that the charge is carried by particles which have mass, but there are 2 variables in this picture. One is the charge and one is the mass of the particles, so he could only calculate the charge-to-mass ratio. What he found is that when he has a negatively charged particle beam, that particle beam will always have the same Q to M charge-to-mass ratio, independent of what material his electrodes are made of. But if he made a positively charged beam, in that case, the charge-to-mass ratio would depend on what element the electrode material was. So his conclusion was that some negatively charged particle, which is same for every element, can be removed from the atoms, and because the atoms are not charged by themselves, the remaining part will carry the positive charge, but because every element has an atom that is different mass, so the charge-to-mass ratio will be different for these remaining parts of the atoms. To actually measure the charge of the electron, Millikan designed a different experiment in 1909, in which he used oil droplets in a vacuum chamber to remove one of the variables, which was the mass. So he did not want to measure the particles by themselves, which had an unknown mass at the time, but he used these oil bubbles for which the mass could be calculated, and once the mass is known, he could calculate the charges. So he used an X-ray source to remove an electron, or 2, maybe 3, maybe 4, from these droplets, and once the electric field is turned on, the movement of these droplets changed based on their charge, and because their masses were already known, from the movement he could calculate the charges of these droplets, which were either 1 electron charge, 2 electron charge, 3 electron charge, so some whole number multiple of the electron charge. And from that, the electron charge and the electron mass were both calculated. Once the electron mass was known, it was kind of interesting that the mass of the electron is much smaller than the mass of the atom, but the small particle is carrying the negative charge. So the atom is large and it is not charged, it's neutral by itself. So where is this positive charge coming from? And the assumption was that because the atom is much more massive than the electron, the positive charge should be spread out in this atom quite evenly, and because the atom is very large, the charge density for this positively charged part of the atom is much lower, while the negative charges are concentrated in these tiny electrons. And this model for the atom was called the plum pudding model, because just like in the plum pudding, the bigger part, which is the pudding, is much more soft, and the hard part, the plum, is the small thing inside the pudding. So here we have spread out positively charged atom which has these very small electrons in it which concentrate all the negative charge. Okay, so this is it for today, and I will see you tomorrow.